Hi there. So what we're going to talk about today is solving systems of three variables. So go ahead and hit pause if you need to, but title a new page, Solving Systems of Three Variables. And when you're ready, we'll begin. All right, example one. We're going to start with a system, okay, that's going to have an x, y, and a z. And what you're going to find here is that if you have a system that has three variables, then you're going to need a minimum of three equations. If you have two unknown variables, you need a minimum of two equations. Okay, so the first type that we're going to see are these types of systems where I have three equations. All three equations have all three variables, and almost every single variable has a coefficient. So when you see a system that looks like this, your best method is going to be an elimination type method, okay? This method's going to be a little bit more procedural, but it's going to do a good job of kind of walking us through beginning to end. All right, so for step number one, here's what we're going to do. I want you to use the first two equations, okay? The first two equations, and eliminate any variable. Okay, eliminate a variable. Okay. Now, it doesn't have to be the first two equations. You could definitely pick the first and the third, the second and the third, but I just think it's easier to just go into it, pick the first two equations. As you get more clever and you get better at it, maybe you could find a better combination. So let's go ahead and let's write out the first two equations right here. So we're going to use 4x plus 2y plus 3z is equal to 1. 2x minus 3y plus 5z is equal to negative 14. One of the most important things with this is being neat, recopying parts of your problems, and going slow. There's so many places that you could potentially make a mistake. So if I say I want to go into this just by looking, I think x is probably going to be the easiest variable to eliminate. So I'm going to multiply this by negative 2. And then what I'm going to do is I'm going to rewrite the equations. This first equation, I am basically multiplying it by 1. So I'm going to just rewrite it. The second equation is being multiplied by negative 2. And again, this is where you want to go slow and go careful because we don't want to make a multiplication mistake. Okay? So we end up with this equation. Now, if we add them together, okay, again, the point of elimination, if we add them, the x's will eliminate. We get 8y minus 7z is equal to 29. Now, from there, I'm done with this equation. It's not going to do me any good to solve for y or z, so let's just go ahead and leave it, and we will come back to that, okay, in just a second. So step two, what you want to do is you need to use two different equations. Okay, so we need to somehow bring in equation number 3 because we have not used that yet. Use two different equations and eliminate the same variable, okay, as step 1. All right, so I'm going to just go ahead and use the second and the third equation. And so I'm going to copy down 2x minus 3y plus 5z is equal to negative 14. And 6x minus y plus 4z is equal to negative 1. Okay, so as we said in the directions, we need to eliminate the same variable as we did in step 1, or else we're not going to make any progress in this problem. So I'm going to multiply this top equation by negative 3 to eliminate the x's. Now let's see what that's going to look like. Let's rewrite this top equation. Negative 6x plus 9y minus 15z is going to equal positive 42. This bottom equation is being multiplied by 1, so I'm going to just basically rewrite this. And let's add the equations together and see what we get here. X's eliminate, get 8y minus 11z is equal to 41. So now let's see what we've got going on, okay? I've got this equation with a y and a z from step number 1, and then I have this equation with a y and a z from step number 2, okay? So what we're going to do next is we are going to, for step 3, you're going to solve the equations from steps 1 and 2. And finally, we'll have our first variable solved for. So the first equation is 8y minus 7z is equal to 29, and the second equation is 8y minus 11z is equal to 41. And so now we're free to eliminate either variable that we want, but I think it's pretty obvious that I think eliminating the y's is going to be the easier choice. So I'm going to multiply one of the equations by -1. Does not matter which one. Negative 8y plus 7z is equal to negative 29. The bottom equation is being multiplied by 1, so I'm going to recopy this down. When I add the equations together, the y's eliminate, and we have negative 4z is going to equal positive 12. Divide both sides by -4, and we have our first variable, z equals -3. Okay, so the most of the work is going to be spent getting your first variable. Go slow, do your work neatly, rewrite as many parts as possible, because if you miss one negative earlier on, the rest of the problem is going to be incorrect. All right, so step 4. Okay, so now what we got to do is, this will be kind of our last step, is you're going to plug in your first solution back into the equations from step 1 or 2, okay? So basically, we can't go back to the beginning of the problem because I don't know enough of the variables, but I can go back and maybe we decide to use this first equation, 8y minus 7z is equal to 29. Well, now what I can do is I can substitute in -7, and we can replace the z here with a -3, okay? And we can go ahead and solve this out. 8y plus 21 equals 29, minus 21 from both sides. 8y is equal to 8, and finally we can see here, when I divide 8 by both sides, I get my second variable, y equals 1. You know what? I am going to make a fifth and final step. Now you need to plug both those solutions, okay? So now we got 2 solutions into one of the original equations. Okay, well, you can probably look back up your page a little bit easier than I can. So let's go back up to the top right here. And you know what? Let's just go ahead and plug it into this first equation. I like to how everything there is positive. And so I have 4x plus 2y plus 3z is equal to 1. So I'm not sure what x is yet, but I can substitute in a 1 for the y. And we can substitute in, what did we say our z was? Our z is -3. We can plug that in for z, and I'm going to solve this equation right here. 4x plus 2 minus 9 equals 1. You might even be able to solve this a little bit quicker than what I'm doing. 4x is equal to 8 if I add 7 to both sides. And finally, we divide both sides by 4, and we come up with x equals 2. So that takes up a little bit of room. I wouldn't be surprised if you're now at a full sheet of paper, okay? These take a lot of work. They take a lot of precision, which is important. So finally, let's talk about the way that you're going to write your final answer, okay? Your final solution is going to be written as an ordered triple. An ordered triple is going to be written as an x-coordinate, a y-coordinate, and a z-coordinate, okay? This is the x, this is the y, and this is the z. Now, I did in class talk about what a system of 3 variables looks like and what the solution would look like visually. So I can definitely share that with you in class next time you're there. Okay, so that is a pretty routine problem for how to solve a system of 3 variables. It was very procedural. We can follow the same steps. It should work. But I want to show you an example where maybe we could mix in a little substitution. Maybe we could use almost a little bit more cleverness to figure out, because I certainly don't want you to think that every time you do these, you have to follow those same 5 steps over and over and over. Okay, so go ahead and write down the second system right here. 4x minus y is equal to 8. All right, hit pause if you need. Let's write down this system. Well, one thing that I noticed right off the bat is that 2 of the equations only have 2 variables. Now, could I put together equation 1 and 3? And the answer is no, because the first one has a y and a z, the third equation has an x and a y, so we don't have the same variables in those. But when you have a couple of equations that only have two variables, we can use a little bit of substitution. So what I'm gonna have you do, okay, for this is we could maybe go into one of the two variable equations and we could solve for y. And so maybe if we solve for y in this third equation. Now, why did I pick the third equation? Because out of the first and the third, y is the only one that does not have a coefficient other than -1. It's the easiest variable to solve for. And so let's go ahead and get this y by itself. And I get -y equals -4x plus 8. Divide by -1. And we have y equals positive 4x minus 8. Now, what can we do with this y equals 4x minus 8? Well, what we can do is we can take the 4x minus 8, and I can go back into my other two equations, and I could substitute it into this y right here in the first equation, and I could substitute 4x minus 8 into the second equation for y. And so this is what we're going to do in step 2, is you're going to substitute, okay, y equals 4x minus 8 into equations 1 and 2. We always need to make sure that we're using all three equations when we do this. And so here's what this is gonna look like. It's gonna look like 5, and we're gonna take out the y and replace it with 4x minus 8. And then it's plus 4z is equal to 6. The second equation is going to look like x plus, take out the y, replace it with 4x minus 8 plus z equals 3. Okay, so now I'm going to scroll up here because I don't need to see those beginning equations anymore. We need to do a little bit of work, and we need to get these equations simplified. So let's distribute the 5. Let's see if we can combine like terms right here. I get 20x minus 40 plus 4z is equal to 6. And so let's simplify more, and we end up with 20x plus 4z, and this is equal 46, because remember what I'm doing right here is I'm adding 40 to both sides. And so this is going to be that first equation. Let's simplify x plus 4x minus 8 plus z. Here's my second equation. Combine like terms, we can add 8 to both sides, and we get 5x plus z is equal to 11. So let's take these two equations and let's put these together, and let's now use substitution or elimination one more time. Okay, so this is now the system that I have now put together. This is a good spot if you want to continue to do substitution. I would maybe solve for the z. I'm going to flip over to elimination just so that you can see that you can actually use both methods within the same problem. And I'm going to multiply this bottom equation by -4 to eliminate the x's. Okay, top equation is 20x plus 4z is equal to 46. The second equation is going to be -20x minus 4z equals -44. So what happens when we go to add these together is our x's eliminate as we wanted to, but we also notice that the z's eliminate. And so we get 0 equals 46 plus -44 is 2. And so what we have here is one of those special systems where we're going to end up with a no solution because 0 does not equal 2. If I ended up with 0 equals 0, this would be an infinitely many solutions. And so that's what we kind of ran through. Is the first one is a good method to use when your problem, all three equations have all three variables. It's a little bit more procedural. But as you get better at this, I'm scroll down to the second example, that we can also find different ways to use substitution and maybe even get through the problem a little bit quicker. So that is the basics. Hope this helped, and we'll see you next time in class.